Hello, everyone. Welcome after the break to the Quality Gems track of the TestCon Europe Conference 2022. Unfortunately, only two gems are left in our track. The first one, Radu Vunvulea. He will tell us about testing the cloud. Radu is a true leader. He enjoys building bridges between people and helping others grow. He shares his knowledge on his personal blog, find it, and at different events and in his spare time. I would enjoy such spare time. He drives an IT community and he is also a Microsoft regional director and Microsoft Azure MVP. So he must know about cloud. Cloud is part of our day to day life, but is cloud testing part of it? Without further ado, Radu, the stage is yours.
Hello, everyone, and welcome to this presentation. First of all, I would like to thank you for joining this session and coming here today, even if we are in a virtual format. So, as you can see on the screen, our topic for today is testing the cloud. Testing in cloud, testing with or without cloud. And my talk is particularly relevant for those of you who are working, who are testing or ensuring that the quality attributes of the applications, of the systems that are running on top of cloud are behave as we would expect. So before going forward, I would like to share with you some statistical information to understand why cloud is important, why cloud became part of our day-to-day life as, for example, social media and so on. And after that, we'll take a look on more details about testing the cloud. So let's take into account that around 50% of the world's corporate data is stored in the cloud at this moment in time. So more or less, we'll need to interact, we'll need to be able to test it, and we need to know how to use it. 90% of large enterprises have adopted a multi-cloud infrastructure. That's great, sounds very good on the paper, but building, testing, and working with it can be pretty hard. I don't know if I'm allowed to say or not in the session, but it's a pain in the ass. Because ensuring that you have the right DR strategy, ensuring that you are doing the right tests and simulate a failover or things like that are not so easy. It's not the complexity on only one vendor, it's the complexity of multiple cloud vendors, and that's not easy to manage and to play around, especially when the tools that you are using are different for each cloud vendor. And in 2025, we'll end up with around 100 zettabytes of data stored in the cloud. That's huge. And that will be a challenge, not only to work with it, but also to move the data from one place to another or to access it. And I would say that in 2025 will be at the moment in time when if we have our data in one of the cloud vendors, there are big chances to remain there because moving them to another place will not be easy. And even with all the tools and the services, still will be pretty challenging. Now, what about cloud testing? Why cloud testing it is so important? If you would be in the room now, I would ask you how many of you use already cloud, and I assume that at least half of the room you would have the hands raised. But if I would ask you how many of you already test cloud system, almost I would say around half of the people, around 50% of the people would raise their hands up. But now, if I would ask you, how many of you have ever went in a training, in a learning thing, where people would share their experience and to cover a learning path that is related to testing in cloud? I don't think that many of you would raise the hands. Or, for example, if you have got a certification for a cloud vendor that is covering testing? These are some tricky questions, and I would say that for now, the cloud vendors are not yet ready for testing the cloud itself. They have a lot of learning paths for development, for DevOps, for infrastructure, architecture, security, data, and you name it, but not too much from the testing point of view, as is from the vendor's point of view. This is one of the main topics that I would like to cover today. So we'll start with what is cloud testing, what are the benefits, what are the challenges, and after that, we'll go forward. And in the second part of the presentation, we'll talk about learning path. What is a learning path that somebody that is doing testing and QA should have on top of cloud? And I will have some hands-on examples in Microsoft Azure, but you'll find similar materials for all each cloud vendors like AWS, Google Cloud, or Alibaba. And we'll talk at the end about the tools, different tools that we can use to be able to test, to do the governance, to do the load and performance tests for our systems. And we'll talk about some of them that are coming from third-party providers. And also there one tool that I would like to focus on that is simulating failover of a DNS inside cloud, of a virtual machine, of a cluster, or simulate a restart of a machine from your infrastructure. That's pretty nice. They are at the beginning, but the tool is pretty nice. If you don't mind, I would like to leave the questions until the end of the presentation. We will have around 5 to 7 minutes for any kind of questions. And also after the presentation, feel free to reach me out over Twitter or over LinkedIn, and we can schedule a virtual coffee. Before going forward, I would like to present myself a little bit more. I'm Radu Vunvulea, Group Head of Cloud for Endava. I'm a big cloud lover. My journey in cloud started in 2010, and starting from then, I would say 95% of my working time and non-working time was invested in cloud, especially on Azure and on AWS. What I'm doing in my free time? Home automation. ESP8266 and a lot of other kind of devices. I had around 110 smart devices inside my house. I'm just playing around, optimizing costs, and now I'm doing pretty nice things, combining different source of energy to heat my house. I will know at the spring if I've done a good investment or not. And also, I'm a big coffee lover. So if you want to have a chat with me about any topic that's related to cloud testing and home automation, let's enjoy a virtual coffee or maybe a physical one if I would be in the same location as you. So let's start. Let's start with the first two items on our agenda. What is cloud testing and what are the challenges? Now, what is cloud testing? There are a lot of definitions and you can find it on Wikipedia, on different papers and so on. But in the end, you have two different dimensions that you are testing. The first one is testing the cloud resources, meaning storage, database, computation, DNS, firewall, security, backups, you name it. This is the first one. The second one is testing the application that reside in the cloud. That is very similar to what we would do on on-prem system, but we get an extra complexity layer, and we'll see a little bit later why. And sometimes can be more easily, otherwise can be a challenge. So it's a combination between these two. And the third one is using cloud as a base tool for QA testing. What is nice, and we used to have this in the past, but from third parties, is the ability to run a performance and to load test and to simulate a load that on-prem system was pretty hard to do. So I remember, I think in 2014, 2013, we were running on our own laptops after hours some agents to be able to spin up a lot of resources, to be able to do some performance tests and do some stress tests. Nowadays, things are much easier. There are a lot of third parties, and there are some cloud vendors that are allowing us to do this very easily. So in 1 or 2 hours time, you can set up and you can schedule, for example, a performance test where you have 10,000, 100,000, or even 1 million users that would simulate a specific test on the platform, on the application that you are using. And something that's changed in the last 3 years is that until 2019, you were required to announce the cloud vendor if you want to run a performance on the load test, just to be sure that they will not block you as a denial of service attack, or just to know that you're doing it. Nowadays, they have tools that are smart enough to be able to detect if you are doing a load of performance test, so you don't need to announce them and to have the confirmation from them. Anytime you can just hit the backend, hit the application, and test it. Benefits and challenges. And let's start with the nice part, with the benefits. It's more cost effectiveness. It's you just use the resources and you pay for the resources that you need to be able to run the test, nothing more than test, nothing more than that. And there are especially two items. One is the resources that you are using to create that workload. And the second one is then testing environment. You can create and keep the environment, the testing environment, only for how long you need it. And if you want to do some changes using a different tier or more or less instances, you can do these kind of changes easily. Availability and collaboration is the second benefit, especially because resources can be accessed from any locations as long as the IT and the infrastructure guide don't limit it. So it's more easily to access, and you don't have any kind of problems with if you have physical access, who will provide that, and so on. Scalability is a very important thing and go hand in hand with cost effectiveness. But for scalability, one thing that we should be aware of is that, for example, you can nowadays test the performance of an application having, for example, more computation power from a more powerful tier and less instances, or uh, lower tier with more instances. What I discovered is that usually applications and systems behave much better if you have lower tiers, for example, virtual machines with only 16 uh, virtual CPUs, but you have more instances of it versus having, for example, a 32 or 64 virtual machine and have only 4 or 8 machines that would do that. Faster testing, it is the fourth one. Customization, and you can play with an environment, change, tweak different things. So it's very easily to do things that in the on-prem systems you would do in a few days if they would allow you. And also the DR and the backups and all the story that is behind it, it's not much easier to implement it, but also to test it, because it's more easily nowadays to turn off the main node or the main the main DNS. Now, there are a lot of other benefits that we could talk about. Let's take a look now on the challenges. First one, security and privacy of data. We lose control. We lose control of the data. Who is storing them, how you can access them, and you rely, in most of the cases, on the cloud vendor. This is something that is more on our mindset and the way how we do business, but it's not so common anymore for customers to ask themselves these kind of things. Multi-cloud models, having a solution that is running on multiple cloud vendors or on on-prem and cloud, and that's nice. It's easy to use, but when you need to do testing, you need to be able to test end to end, but also each cloud vendor. And you can have there are some hiccups because you have the latency of the cloud vendor, you have the latency between the cloud vendors. You might have capability to simulate different failovers in one cloud vendor, but on another one you wouldn't have, and so on. The third one is developing the environment. And even if it's very easy to spin up the environment, the problem with the environment is that you might not have the same performance, the same throughput on the same tiers all the time. If you don't have dedicated tiers and you are in a tier where some resources might be shared by multiple customers, like connectivity, uh, database servers, and so on, you could have a test today and get specific output, specific KPIs, and tomorrow in 10 days' time, you would have different ones and are not related to how the application was built, is related to the environment that is used for testing. And this goes hand in hand with replicating the user environments, where you can create similar environments, but all the time there might be some small discrepancies that can create you some hiccups. And because you lose control of some infrastructure, especially layers, testing across the full IT system end to end, it's not all the time possible. Or you might not be allowed to do anything or any kind of failover. Just to give an example, if you're in a physical environment, it would be very easily for you to simulate what would happen when a, a virtual card would fail. On a cloud environment, you don't have access to it. Yeah, you could remove it, but you are not able to remove it when the machine is running. So you might need to rethink the ways how you're covering different testing flows and how you're tackling them. And of course, as environment control has some limitation, and you can test, but you cannot test all the time end to end. Now, let's talk about the learning paths. And we talk about the learning paths. Um, the biggest challenge that I found on the testing side is that they're not there's not too much content for learning. What I mean by that? For example, Microsoft Azure at this moment in time, they don't have any kind of certifications from the Azure point of view that are specific for a QA tester. The same thing is for AWS, for Google Cloud. They have learning path and they have certification for different skills for different roles, like for example solution architect, database, networking, security, ML, data scientist, you name it, but nothing for testing. Even if you take a look on the learning path, you might find content there and there and there on different learning paths, but you don't have a learning path as is. I saw that there are some third-party learning vendors that have learning paths for QA, for testing in the cloud, but nevertheless, they are not official ones that would be provided or approved by cloud vendors. So the first thing or the biggest challenge is usually, okay, you want to learn, you want to go through an upskilling program and to understand better the cloud, what you could do, what you could learn. Yes, you could identify that. For example, cloud practitioner certification combined with database and security might be something good to you and useful, but there are some areas that you don't have interest or they don't are not useful. So a tester should be able to test an application that is on top of cloud services and on top of cloud infrastructure, and you should have that learning path, that journey. I would like to share with you what are the 5 pillars that I think that are relevant and useful from the testing point of view that a tester or a QA should know to be able to run tests inside the cloud easily. So the 5 pillars are core cloud knowledge, CI/CD infrastructure as code, storage and database, monitoring and logs, and what is the most common application specs. Now, don't think that we need to go or you need to go in details in all of them, but there are some concepts that needs to be understood to make your life much easier. Uh, for example, infrastructure as code. It's pretty important because if you want to modify how a specific environment is hydrated, with what kind of services of the number of instances, you should be able to understand a little bit uh, that infrastructure as code and to be able to modify it. So don't think about all these items. You need to fully be proficient on that, but you need to be able to modify or to trigger, for example, a load test from Azure DevOps, or to define the performance test through the tools that different vendors are providing. The same thing for database and storage. It's very important to know exactly how you can get access to it to be able to fetch data. Logs and monitoring to be able to know what kind of data are behind the scene. So let's take step by step all these 5 pillars and go a little bit in more details. And let's start with the core cloud knowledge. And what we are referring here is about cloud concepts. In most of the cases, you are very familiar with them. The second thing is cloud services. And now, yeah, each cloud vendor has 250, 300 different services, and we shouldn't focus on all of them. What I highly recommend you to do, take a look on the services that are more common or are used by the company that you work for or for the customer, and just focus on them. And this is why we have the most common application stack at the end, because basically through it you understand exactly what are the services that are relevant and you should be aware of, at least what they are doing, how you communicate with them, and how you can exchange data. And also, cloud management and governance, a little bit of it is pretty important to be able to know how you can manage the content, how you can govern it a little bit from the security, or how the security is handled, how the costs are tracked, and so on. If, for example, we take AWS or Azure, these concepts are covered by Azure Fundamentals Learning Path, or or AWS Practitioner certification. The second one is the CI/CD infrastructure as code. If we go with an example on Microsoft Azure, it's just, for example, the concepts, how you use Azure DevOps, how you interact with it, how you can run the quality test inside pipelines, inside Azure pipelines, how you run functional tests inside the pipelines, how you can run the load tests inside Azure DevOps, and also to have a high-level overview of ARM or Terraform. And talking about this, as you can see here, there are a lot of things that you can do through Azure DevOps or similar tool that each cloud vendor is providing. You can include the functional tests or the load tests inside them, and you have the ability to run them and to be part in the end of the pipeline, and even to have a build that fails depending on what kind of condition you are configuring. The third one is storage and database, where the most important thing here is about uh, to know how to access different storages, how to get the information, and to be able to analyze it, or how to connect that storages, the databases, to the system, to the tools that you are using to ensure the data uh, is written there, or the right data is already persisted there, and so on. And there are some specific tools. If you're talking about Azure, like for example, Azure Storage Explorer, that might give you a hand, and other web applications that just provide you seamless access to the storages, giving you the ability to modify them, to change them, and so on. Most of the cases, each cloud vendor, through their consoles, through their web portals, have something like a data explorer or a storage explorer, giving you the ability to get inside the data that is already stored there, to be able to upload, download, verify, and so on. The fourth thing is logs and monitoring. And over here, I will I think it is important to have a high level overview about what are the tools that are used in the monitoring side on each cloud vendor. If you're talking about, for example, about Azure, we have the Azure monitoring, we have application insights that are very, very common. And to be able to collect logs from the infrastructure, from the application, different metrics, that, for example, from the users that are collected, and how you can access them, and how you can take a look on them in a consolidated way, in a such a way to be able to provide you the information that you are looking for. The last one are the most common application stacks. And what I've seen on the market, at least for now, we have applications that are built on top of Kubernetes, web applications, and also data-driven application. But the first two, I would say, that are the most common ones. If, for example, you Bing it on Google or Google on Bing, you will find that each of these items that we talked today, and just wanted to let you know that each of them is just a title from a learning pad that Microsoft Azure is providing, are a subsection of a learning pad. So in the end, as you can see, there's a lot of content from Cloud Vendor, but you need to know exactly how to look, how to combine to get that story, the story that uh, it's building the learning experience that is more closer to your day-to-day activities. Now, let's go on the last topic for today, testing tools. There are a lot of tools that are on the market. Some of them were also on-prem, and they were just enabled them to be able to run on-site cloud. Some of them are cloud native or are provided by cloud vendor. And I would like to talk with you about some of them, just to provide you the context and what what we have on the market. I'm not covering all of them. I have 5 or 6 that I would like to tackle a little bit. The first one is Swasta Cloud Test, that basically facilitates to simulate almost 1 million users, and they have the ability to simulate them from different locations. So it's very easily, for example, to run functional or performance tests on mobile and web-based application. Of course, they're coming with nice dashboards, metrics, and so on to be able to identify what is the sweet point, what is the breaking point, to understand the behavior, and so on. It's a pretty nice tool. I don't find it very easy to test, but still it's a pretty good tool. The second tool that I would like to talk about are Azure Load Testing and Azure Chaos. And let's start with each of them. Azure Load Testing, it is a tool that is provided inside Azure portal, and let me share my screen just to show to you a little bit. And what is allowing us to do is basically to be able to run a test on Azure Load Test. And the nice part here is that when you want to run the test, you can decide if you want to run just a simple load test, or you can take your JMeter script that you have already built or prepared, upload them, and decide how you want to run them. So, for example, let's take this example. I just prepare a mock website, and very easily we can, for example, let's simulate on this one, let's say a load of 5,000 users. Test duration, let's say 60 seconds, not take a while, and no ramp up. And we would hit run. And that's it. You don't need to do anything more than that. If we would have some JMetric scripts, we would very easily be able to include there. Now it is provisioning, it will start. We can monitor in real time, and after it will finish, I just to share with you something that I already have there. Oh yeah, and I really love the sign in that is pop up each time when you do a presentation or a demo. So let's give it a while. And if you take a look, for example, on the test that's already run, let's take a look if this one already started. It's still warming up, but we already have 2 of them. And for example, if we would go on the one that I ran, this is running now. Let's take on the one that I was playing yesterday. What we could do very easily, for example, we can compare. So we can decide, let's go in this one, and we could compare the results with the other ones. Also, from the metrics point of view, you have the client-side metrics, but because our application is running inside Microsoft Azure, also we have the backend metrics, and you can have consolidated view. You can decide exactly what you would like to see, how you would like to see that information. So it's very easy to integrate, for example, in a pipeline. in Azure DevOps, or in any other location. As I said, to be able to compare them, for example, let's compare this two, and we will be able to see exactly how the system behave, if there are any kind of if there are any kind of differences. This is still provisioning, so let's give it more time. So for example, these are two tests, one that ran yesterday afternoon, one in this morning, and we can see exactly how the system behaved each time, what were the what was what was the output, what was the latency, the CPU usage, the number of service requests, and so on. So this is an out-of-the-shelf solution provided by Microsoft to be able to run load test or performance test. Now, another big challenge that we have in our day-to-day is how we can simulate a failover. And it's pretty tricky because at application layer might be with specific gate more easily. On infrastructure where you have control, you can do it not so hard because you have uh, physical access. For the one that is running somewhere in the cloud and you don't have access to it, things become more complicated. If you put on top of it the governance, the security layer, and so on, things are harder and harder. So Microsoft now is providing, and it's still in previous, um, Chaos Studio. And it's pretty nice, and it's very easy to use. So you just need to specify what kind of infrastructure you have, and you need to specify exactly what you like to happen. So for let's give it let's give it a try. I already have an experiment already, but I would just want to show to you how easily you can do it. For example,
Radu,
uh, yes,
do you think you can zoom in a little bit?
yes, of course.
Thank you.
Thank you for letting me know. So let's take a look on if load test started to run, warm up. So let's give it a little bit more time. And now we will need to create an experiment. We will need to specify exactly what is the resource group. Let's say that on this one, I would use the RV resource group that I've created for you. Uh, Let me zoom out it. But we'll end up with an experiment like this, and we can create a new we could create a new experiment. And what we need to specify on the experiment, it is the resource group. One second, we have this one that is dedicated, a new of the experiment 2, East US, it's perfect. And then we would go to design. And now when we are talking about design, here we have the ability to specify exactly what we would like to happen. So for example, on the action, and this is one of the coolest parts, it is, for example, we can simulate a fault. And let me zoom on the other side, where on the fault we have a full list of what is supported now, but please take into account that they're still in the preview phase, it's not released, so more will be added. For example, you can specify, you can simulate a fail of a pod. Of, or for example, that you have a reboot of Redis cache, or a Cosmos DB failover to see exactly how the system would behave if the main uh, node fails. Or you can simulate the CPU pressure to the virtual machines, or DNS failure. And the DNS one, I really like it because in at least in the cloud, it's not very easy to do this, or issues with network, or from the security point of view. You can even have, for example, at VMs, if you have a VM that is shut down, or a scale set that is a group of virtual machines. So you have the ability very easily to simulate it. And let's go on Cosmos DB. I just want to show to you how easily this can be done. you need to specify the duration where this will take place, and after that, you need to specify the target based on the subscription that you have access. You just need to specify uh, on which one, and that's it. Nothing more than that. So you can simulate a failover of some Azure services and infrastructure pretty easily. Uh, More faults will be added soon, so expect this to um, have more and more resources. In the meantime, it seems that also the load test started. So as you can see, I already see 404 errors. Let me also integrate it with metrics from the backend, and basically these are the ones that are now tested. And now we can see client-side metrics from the load test that is running at this moment in time with, I don't remember exactly how many users I simulate, I think 1,000 or something like that, or 5,000. Now we have, for example, 2.5 thousand users that are active. And also we can take a look behind the scene uh, from what is the load of the CPU, the response time, insights related to the application insight, and so on. So highly recommend to take a look, especially on Azure Cloud, because it's pretty cool if you're using Microsoft Azure. What other tools we have? We have the LoadStorm. Is for great, especially for load tests. Very similar to the previous tools that we talked about. Nessus, it's for security vulnerability scanning, and especially if you don't have the right configuration, it's more on the infrastructure security side, but it's very, very useful because it can automatically part of your day-to-day activities. And before going to final thoughts, just let's take a look if the load test finish, it's still running, but as you can see, we already see errors, and we put it a system down. So for example, the response time now went to around, we have around 500 response per second. And if you take a look on the errors, we can already see that from the total of 2,000 requests, we already have 400 errors. Having that system integrated with application insight would be very easily to see exactly what happened behind the scene. So, what are the final thoughts? And the final thoughts from my side are going on two different views. The first one is upskilling program, and even if we don't have yet an learning path for testing from cloud vendors, still, if you identify exactly the skills and the information that you are looking for, you will find in their learning path and in their learning curricula areas that you can share. I have a learning curricula for testing on my personal blog for Azure. Let me know if you would like to have something similar to GCP on AWS, because I didn't share it with them publicly yet. And from the cloud automation point of view, take a look on the automation tools for load test, performance test, and for testing failure of different systems that are cloud native for each specific cloud vendor. Because tools like the one that I showed to you a little bit before are the tools that enable us to make our testing easier when we are working with cloud. Thank you. Thank you for having me here. I hope that you enjoyed the presentation. And now it is a perfect time for the Q&A session. And in the meantime, I will leave uh, this screen open just to get more insight about how the system behave during the tests and what kind of other information we have here.
Thank you so much, Radu. Thank you for the detailed demonstration. To see it in action, it was very valuable. We have one question so far. It's from Patricia. Could we say that the cloud testing is production testing? I mean, are we testing on real test data?
Uh, Let me refine the question. The question is, can we only test on production environments or also for non-production environments or on real data? No, you can also have testing environments, performance testing environments, and so on. Like for on-premise systems, it is up to us to decide if we want to use a pre-prod environment or another environment that we are creating and what kind of data we are putting in there. Um, a small flavor that we should consider it is that when we recreate the environment from scratch for testing, we should ensure that we have, for example, infrastructure as code, and we are using the one that that is used for the production environment, and ensure that you have at least the same data from the volume and complexity point of view that also you have in the production environment, because the complexity of the data is very important and could affect the output of your tests.
I hope this answers. We have another question. Any tool you can suggest for Windows desktop app testing in cloud?
So the question is related to if I could suggest a tool for Windows desktop application testing in cloud. It's not clear for me if you have the desktop application running inside the cloud or on on-prem system. Um, so if you're referring to simulate a payload on a desktop application, uh, I'm not aware of a dedicated one that can be used only from the cloud to generate the payload that is running on a Windows desktop that you have. But for example, but if you want to define the load test and how it is running and so on, for example, you have the integration with the low test that Microsoft is providing with Visual Studio and so on, where you can do a recording or define the scripts similar to one that you have on JMetric, and to play with them.
So it's a desktop app that is running in the cloud.
A desktop application that is running inside the cloud, I assume on top of Azure virtual machines. In this situation, you would just need to use the same tool that you are using for on-premise testing, because in the end it is still a desktop. It is a desktop application. Nevertheless, Azure Cloud Studio could be useful to be able to simulate failover of infrastructure. Like, for example, what would happen if a process or a task would fail, or a restart of the service, or to put pressure on memory, on disk, and so on.
And they're actually looking for UI testing desktop app.
I'm not aware of specific tools for UI testing apps, so I'm more on the cloud side. But you can use the engine that you have on inside the cloud to be able to run that test. Virtual machines, Azure DevOps, and so on.
All right. And I think it's going to be the last question from Hannah. Are there differences from test design point of view between AWS and Azure cloud testing? Have you seen it?
Ah, that's a very good question, and thank you for Hannah for that. So if we test it in a different ways, if we have AWS, or GCP, or a Microsoft Azure environment, and yes, you would test it differently. Why? Because the functionality and the tools that each cloud vendor is providing to you to be able to simulate a payload or a failover of a specific system will be different. If you only have, let's say, the virtual machines in each cloud vendor and nothing more than that, you will say that it's pretty close one to the other. But because we are using different services from each cloud vendor, how you simulate a payload on that, or a failover, it is different. Uh, for example, in one way, you are simulate a DNS failover on AWS. In a different way, you are doing it in Azure. There might be providers that would not allow you to do that. Or um, another thing that is, especially from the performance, usually it's very hard to compare a tier between different cloud vendors. It's like uh, different fruits, apple and pears and things like that. Because even if you have the same number of virtual CPU and the memory, disk, and so on, in the end there will be different virtual infrastructure and they will behave very different. In most of the cases, usually people compare the cost of running versus the load that can be managed by that system.
Oh, we have one more question. Is it somewhere? Let me see. Can cloud testing in practice exist without numerous automation tests? Do you see such examples in real life?
Yeah. So, if cloud tests can exist without automation testing or the tool that would enable us to do automation, uh, if you would test mostly the UI, yes, but you will need a lot of people doing that kind of things. But it would be a little bit challenge, especially when you do more load and performance tests or stress tests and not only functional tests. Functional tests in the end can be done also manually or automatically because you executing different flows and you take a look on the output. An output can be on the user interface or can be in the database, in the logs, and so on. But at the moment in time when you're talking about stress tests, then you might need, okay, how I can do this manually? Well, I would need 1,000 people doing the same thing at the same time as, for example, you would have testing on on-prem systems.
Again, thank you, Radu. It was very useful, I'm sure. You've also provided us with various topics to continue browsing and learning about cloud testing. Most of us probably work somehow in the clouds and we use clouds. So thank you so much. Thank you, everyone. And we'll see you in the next session.
Thank you and have a great day. Cheers.
You too.